Okay, so that's how we work out molecules. Now I'm going to do a couple more examples of these because it's really common in the exam that they ask you to work out the number of molecules in a reaction. It's more common that it's asked with the gas laws, but if you can do it here, you can do it with the gas laws later on. So we're now going to look at page 14 of your notes. And we're going to try one of the practice questions. So question 1 on page 14. Calculate the number of molecules in 0.5 moles of sulfur dioxide. Okay, so now again, I'm given the number of moles and I just want molecules. So molecules is moles times Avogadro. So it's going to be 0.5 times 6.02 by 10 to the 23, which is 3. And that's your final answer. Let's do one where we have to do something else first. Let's do number 3. So you're asked to calculate the number of molecules in 1.2 grams of methane. So again, we've got CH4 coming up. Now there's a reason I keep mentioning methane. And when you do organic chemistry, you'll see why. It's really important that you get to grips with the names in organic chemistry. So meth means 1 carbon, and ane tells me they're all single bonds. So that's what the structure of methane will be. We'll go through all that in organic chemistry. Right, 1.2 grams of methane. In order to get molecules, it's moles times Avogadro. But I don't know how many moles are in this yet. So my first thing is to work out moles. So it's mass over RMM. Now, we're given the mass over the RMM. So we're going to work it out. We've got 12 plus 4 times 1, 1.2 over 16. And when you divide that, you're going to get 0.075 moles. Next, once you have moles, then you can work out molecules. Because it's moles times Avogadro. So it's 0.075 times 6.02 by 10 to the 23, which is going to give me 4.5. 15 by 10 to the 22. And that's how many molecules of methane are in 1.2 grams. Now, there's a few there for you to practice. It does come up quite often. We're going to see it again in the gas laws chapter, but thing to remember, it's moles times Avogadro. Now, leading on from this, atoms. Atoms is something that started to appear on the exam more often, and it started to come up in the last about 5 years or so. It tends to not be answered very well, and I'll explain why. When you have molecules, this is how many molecules of methane. So in 1.2 grams, I have 4.5 by 10 to the 22 of these in that 1.2 grams. Now, if I want the number of atoms, this is what the junior cycle has to answer for. Atoms and molecules and particles are not interchangeable. So you've probably heard from junior cycle that you have 4.515 by 10 to the 22 particles of something. In this case, it's 4.515 by 10 to the 22 molecules. So molecules is not the same as atoms. In a molecule, there are 5 atoms. You've got 1, 2, 3, 4, 5. So to find out how many atoms are in that 1.2 grams of methane, you take your number of molecules and you multiply it by the number of atoms. So in this case, you take that and you would multiply it by 5. So let's look at some more examples of that. still on number 4. We're doing atoms. Now, in this one, we're on page 15. Now, some of you may have written this out when you were in class about how to get from moles to molecules to atoms. So to get from moles to molecules, you multiply by Avogadro's number. To get from molecules to atoms, you multiply by the number of atoms. And if you want to go back the way, you're going to divide. So if you're given the number of atoms in a sample and you're asked for the number of molecules, you then divide the number of atoms by the number of atoms in the molecule. And in that case, in methane's case, it would be 5. And if I have molecules and I want moles, you divide by Avogadro's number, which is 6.02. Now, I'm not overly fond of just memorizing that. I'd rather use the triangles. If you want to do it this way, that's absolutely fine, and it is correct. I just find it's a little bit easier if you're understanding what's happening rather than just learning that off. Okay. So, on page 15, there's a worked example. So we're working at the number of atoms in 0.07 moles of water. Now, in order to find atoms, I need molecules first. So we're starting with moles. So we need molecules. So you take the number of moles and multiply by Avogadro. So that's how many molecules of water there is in 0.07 moles. Now, to get atoms, you take this and you multiply it by the number of atoms in water. So water has the structure H2O. It has 1, 2, 3 atoms. So you're going to multiply the number of molecules by 3 to find the number of atoms. I'm just going to times that by 3, which will give me 1.2642 by 10 to the power of 23. So it's quite a big number. Now, one thing I'm going to point out here is why do we use moles and not just talk about numbers of molecules? Surely that's more relevant. We're lazy. Chemists are lazy people, and this is a really big, complicated number. When you've done chemistry for long enough, you'll see that that number relates to this number, and you'll be able to see that. But at the minute, if you put all of these into a textbook and you're just dealing with numbers of molecules, it's hard to look at. They're very, very big numbers. Whereas when you look at moles, it still relates to the number of molecules, but it's a much smaller number and it's a much larger number, sorry, and it's much easier for someone to deal with in calculations. And that's atoms. Now there's quite a few of these for you to practice because they're getting more popular. So on page 16, there are 6 questions for you to have a go at, and on page 17 there is an exam question from 2010. Now, yes, it is quite a long time ago. The reason I haven't put a more recent one in there is it's more commonly asked in the gas laws questions, which we haven't gone through yet. So you're going to see this again in the next calculations class. And the answers are on page 17 as well. Now we're going to get to the good stuff. On page 18, we're going to look at how do you calculate how much of something is formed in a reaction. So we're going to need 2 boards for this. For the next one, we're going to have a look at calculating the amount of substance formed in a reaction. Now, this is where the big marks are. This can be worth about 12 marks depending on the question and how many hoops you need to jump through to get there. So on page 18, I have done out a worked example that I'm going to go through on the board, and I'm going to do basically just this for the rest of class. It's so important that you get the steps right in this one. So the worked example tells me in this reaction, so I've got sodium plus ethanol to give me CH3, CH2, ONA plus H2O. Oh, sorry, 0.5 H2. Now, you may or may not have seen this before. 0.5 H2 is fine. When we read a balanced equation like this, now this is key, so you really need to pay attention to this. The numbers in front in the balanced equation tells me how many moles of each substance reacts together and how many moles are going to be formed. So when we look at this, there's a 1 in front of the sodium. That means 1 mole of sodium reacts with 1 mole of my ethanol. And it forms 1 mole of my product and 0.5 moles, half a mole of hydrogen. Now, we're going to use that information to work out how much of the product is formed. So let's go back to our question. 1.2 grams of sodium reacts with excess ethanol in the reaction below. Calculate the mass of our product formed for 12 marks. Now, I'm going to get rid of this and I'm going to make a table underneath my balanced equation. And I cannot stress, as an examiner, how important it is that you lay this out nicely for your examiner. There is nothing worse as an examiner than having a load of calculations scattered all over the page and we haven't a clue where you've even started from. Having it laid out nice and neatly lets us look and go, just go, doo, 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 done, 12 marks. We don't even need to think about it. Whereas if you've got a jumble of numbers, you might have the correct answer in there somewhere, but we have to work to find it and it's very easy to miss it. So lay it out nice and neatly for them so they can just move on. And that will also mean that you're going to maximize your marks as well. So how I would recommend it is to do it as a table. And everything to do with this reaction is going to be filled into this table. Now, for moles, we need our mass, we need the RMM, and we need moles. So we've got grams per mole, and the units for moles is just mole. Okay, and we're going to fill in what we know for each of these substances into the table. So the only thing we're given is 1.2 grams of sodium. Now your ethanol, it actually hasn't told you anything about the ethanol, so I'm going to ignore it. You will either be told that the reaction is using excess ethanol, which means there's more of it than you need to react fully with the sodium, or it doesn't mention it at all, and if it doesn't mention it, you don't care about it. So I'm just going to completely ignore ethanol. Now, the question asked me to find this. I need to start from here and work my way across the table up to here. And you're going to do it stepwise. So like a checkers board or a chessboard, you're going to move like that. Nice and stepwise. So, in order to move down the board, I need the relative molecular mass of sodium. Now in this case it's the atomic mass, which you get from the periodic table, which is 23. Now to get moles, it's mass divided by the RMM. So it's 1.2 over 23, which is 0.052179. Now, a lot of you are going to look at me and think, why don't you just round it off here? No. Don't round anything until you get to the end. If you round here, and I left it as 0.05, that can affect what your final answer is going to come out as, and it might not be within the acceptable range, even though your method is correct. So then you'll end up losing 3 marks at the end for not having the right answer. Okay? Now, we know the number of moles of sodium that reacted with ethanol, and we're going to use that to figure out how many moles of our product. Now, this is the trickiest part from this. To get to here, you've got 3 marks. No, you didn't get marks for writing in the RMM for the sodium, but that doesn't matter. You've got 3 just for getting the moles here. Now, if we look at the balanced equation, and we look at sodium and the product, we need to look at the relationship between the two from the balanced equation. 1 mole of sodium reacts to give me 1 mole of product. So there's a 1:1 ratio between them. So however many moles of sodium I start with, you're going to form the same number of moles of the product. Now we're going to fill that into the table. The ratio is 1:1. We don't have 1 mole in this reaction. 1 mole is much bigger than what we actually have. So instead of having 1 mole, we used 0.05 moles of sodium. Now, to figure out how many moles of your product you form, it's going to be the same because of the 1:1 ratio. If that was 1:2, and I'm going to show you a reaction like that in a minute, the number of moles formed would be twice as big as what you started with. So the number of moles is this. In your exam, underline that, showing that that's the number of moles of the product. That's going to get you another 3. Now let's move up to here. We're nearly at the point where we can work out the mass. So I've got moles and I want mass. So if we look at our lovely triangle over here, to get mass, I need to take the moles and multiply it by the relative molecular mass. So I need the RMM. Please show your calculation for RMM in here. No shortcuts, because this is one of the tricky ones. So if we look at the carbons first, we've got 2 of them. That's carbon. Hydrogens, we have 3 and 2 is 5. Oxygen, there's 1 of them and it's 16. And sodium is 23. Add those all together and you get, on the next page, you're going to get 68. Now, you don't get marks for having calculated that, but you're going to get marks for using it. I'm going to write the formula in here. Once I know the number of moles and I know the RMM, I can work out mass. Because your mass is moles times RMM. So we're going to take the number of moles from here and the RMM from here and multiply them. So it's 0.052179 times 68. So the mass of our product formed is going to work out as 3.55 grams. Now, where do we get marks here? You get marks for writing that out. So that's 3, and you get marks for the final answer. Don't forget your units. Units really annoy me as an examiner when they're not included. And you're going to hear this if you do other online courses as well. If you don't put grams in there, that could be 3.55 anything, milligrams, micrograms, kilograms, tons. I want to see the units, because that shows me clearly that you understand what's happening here, and I don't need to then dig through the rest of the question. If you look at the mark schemes, the unit grams will not be in bold, so you don't get marks for having it, but please put it in. Now, if we wanted to, I haven't included this, I'm going to get my calculator. We could, in theory, have worked out the mass of hydrogen. And that's why the table is so useful, particularly if you have more than one calculation happening in here. So if I wanted to work out the mass of my hydrogen, let's go that way. We need to look at the relationship between sodium and hydrogen. And that ratio is 1:1/2. 1 mole of sodium will make 0.5 moles of hydrogen in this reaction. So you will end up with half of what you started with. So if we have 0.052179, that's how many moles of sodium that we started with. The number of moles of hydrogen is going to be half that. So let's do it. I'm not doing that in my head. Which is 0.0260865. Now, as you can see, when you're doing this out in the exam, use the whole width of the page. So I was very silly and I didn't just bring it to the edge of the board, but you're going to be more intelligent. Now, for hydrogen, the relative molecular mass of hydrogen, there's 2 of them, the mass is 1, so the RMM is 2. And then same again, in order to get mass, it's moles times RMM. So these 2 multiplied by each other. So 0.0260865 times 2. 0.052 grams. And that's how many grams of hydrogen that you formed in that reaction. If I wanted to be pedantic and work out the number of moles of ethanol needed to react with that number of moles of sodium, you can also work that out here by comparing the ratio of the number of moles. Right, let's do way more of these. Okay. Let's do one where it's not 1:1. So, if we look at the worked example on page 22. Now, as you look at my notes, you'll see that they're quite long for this because I'm literally going through each step individually and telling you where these numbers came from. In your exam, this is all you will write. So one table with everything in the one table. And you're going to make it very clear for your examiner what your answer is. So if the first part of the question asked you calculate moles of sodium that reacted, you're either going to draw a box around it, or say for part 1, that way your examiner just goes, oh yes, that's fine, that's right, full marks. 2, if they then asked you calculate the number of moles of your product, full marks. And in the last question it would ask you calculate the mass, then your mass would be 3.55 grams. So either draw a box around the correct answers and label them, or your examiner should be able to work through them and find it for themselves, but when you're correcting 30 papers a day, this is very tiring to do. So spell it out for them, make it very clear what your answer is, and then your examiner will be delighted and will just mark it and move on.